This Twitter argument over Common Core math has me conflicted. The account End Wokeness tweeted out a video, which we'll watch in a moment, of a child doing math in the new Common Core way compared to an adult doing math in the classic way. And math professor Daniel Litt replies saying that if you don't recognize these two approaches are essentially the same thing, then I think you may not be very interested in math at all. And I'm conflicted because, on the one hand, if an account called End Wokeness and a math professor are arguing over math education, then I have a very strong prior to assume that the math professor is probably right. But on the other hand, Daniel Litt doesn't seem to be making a very good argument here.
1, and I'll go 1 plus 4 is 5 plus 1 is 6. That's my answer.
Learn how you show how it's actually done.
How it's actually done. Okay.
These are the tens and that's the ones.
Okay.
4 tens and 1, 2, 3, 4, 5, 6, 7.
Okay, that's...
And then 7 ones. And
okay.
then 1 more 10.
Okay.
And 1, 2, 3, 4, 5.
Okay.
6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
wow.
11, 12, 14, 10, 20, 30, 40, 50. Okay, this wants to be with its friends, so it goes up to 50 and then it counts one more up, so it will make 63. That's how you do it.
Okay, times have definitely changed.
The case for classic math is that it's faster. It requires making fewer marks. You only need the Arabic numerals and not the dots and tallies of the Common Core approach. And adults in the children's lives probably know how to do classic math and perhaps don't know how to do the Common Core math. So with the classic approach, kids could get help from their parents, and that might not be available with the Common Core approach. The case for the Common Core approach is that it trades off speed of calculation for comprehension, understanding what's actually happening. Children might not understand what it means to carry the one or why you would do that. And as we see in the video, what the child does is make that abstract process more concrete with the dots and shifting them from the ones column to the tens column. And spending that extra time might help children understand math better. And in a world where we all have access to computers to do calculation for us, perhaps it makes sense to trade speed of calculation for comprehension so that the human can understand what's going on with the math and why, and ask a computer to do it for the human to get a quick answer back. I think that's where Daniel Litt's argument is coming from. It's fundamentally the same algorithm, just the symbols used to execute that algorithm are a little bit different. And if the Common Core approach helps students better understand what's going on, that will better equip students for modern life and mathematics in modern life. But this argument relies on the assumption that the Common Core approach does help students understand math better. And I'm not sure that assumption is true. What would we expect to see if Common Core did help students understand math better? Well, I would expect to see improved scores on standardized tests. Common Core was introduced in 2010, and states adopted it between 2010 and 2014. Here, we're looking at 8th grade math scores on national assessment tests in yellow between 2003 and 2022. And the takeaway is that even excluding the pandemic, just going up to 2019, the change we see is a small decline in math scores. And that's similar to a small decline in reading scores over the same time period. If, instead of looking at scores, we graph the percentage of students who attain a basic or higher level understanding of math, then we find the same thing, a slight decline that's similar to the decline in reading comprehension. 4 states never adopted Common Core, and 5 more states adopted the Common Core standards and then reversed them. If we compare the trends in the 40 states that just adopted Common Core standards, we see similar outcomes. That is, all states averaged about a 9-point decline on the test scores, a decline of about 12 percentage points in terms of students testing at the basic proficiency level, and a decline of 8 percentage points in terms of students testing at the advanced proficiency level in math. The fact that there's very little difference between the states who adopted Common Core and the states that did not make it hard to tell if Common Core did anything. On the PISA tests, which are a standardized test that compares education across many different countries, we see that in the United States, scores on math declined over this time period, even while reading was stable and science was improving. From looking at test scores, it's hard to tell that the Common Core math standards did anything. Of course, it's possible that they improved students' deeper fundamental understanding, but just in a way that we can't detect on tests. But it's also possible that they did not do that and didn't really improve students' fundamental understanding. So I agree with Daniel Litt that the two algorithms are basically the same. And I further agree that if the Common Core approach helped students understand math better, then trading calculation speed for comprehension is a very good trade-off. But it's not clear to me that we achieved the greater comprehension. And trading calculation speed and simplicity of calculation for nothing, well, that doesn't seem like a very good trade-off. And if the Common Core approach to math hasn't helped students understand math better, then I think it was a mistake to have done that. Not only because it required a bunch of time and effort for teachers to learn a new approach, and also it alienated parents from the process of helping their kids with math, and also it gave up calculation speed and efficiency, but also because instead of adopting Common Core math, we could have done some alternative that actually did help improve students' deeper fundamental understanding. I looked for evidence that Common Core math helped students actually understand math better, but I didn't find it. Of course, I only did a short search looking for it, so it's very possible I'm missing something. And if I am, I'd love to learn more. Thanks for your time.